Alright, so now, even higher level of understanding, accountability, attention to detail. Here we go. It says a man is in a boat 2 miles in the ocean from the nearest point on the coast. He is to go to a town located 3 miles down the coast and 1 mile inland. If you don't get out of the house much and play a lot of Fortnite, it's going to be hard to draw this picture. Okay, but picture yourself as far as what this looks like. So he can swim at 2 miles an hour and walk at 4 miles per hour. Toward what point on the coast should he swim in order to reach the town as quickly as possible? So this almost feels like one of those Algebra 1 problems of the train is traveling at this, and all that good stuff. But this is much more intense, okay? So, first of all, someone asked, why didn't he just, what's going on? Why is he out there? Why is he trying to swim? He's in a boat. Okay, so let's pretend like the boat ran out of gas. Okay, so he's swimming, and we're going to draw this picture. So here's his boat. Okay, and he is 2 miles from the nearest shore. And then it says 3 miles down the coast, and then 1 mile inland, is where he's going to this town. Okay? So here's the boat, 3 miles down, there's this town. And we're trying to make this 2 words. What are we doing?
Minimize time.
Minimize time. Okay, here we go. Write them out. Minimize time. Could the person do this? Could the person go straight, then to the right, then up? Could they do that? Yeah. Would that, in your intuition, be the quickest?
No.
No. Because the fastest point between, or the fastest, shortest distance between 2 points usually is a straight line. This could be a possibility, but we swim at different rates than what we walk. You with me? So this is even higher level. So here we go. What I'm going to do is I'm going to say that this distance, this almost feels like a shadow problem with the street lamp. We're going to label this as X. This is a little terrible for sure. What do you think this equals?
Y.
No, not Y.
Oh.
Oh, was that W-H-Y or Y?
Both.
Okay.
3 minus X.
Yes, 3 minus X. Okay. From the way the problem was given to us, this is a right angle and this is a right angle. And what we're trying to do is minimize time, or time. Sorry. So we're going to minimize time. All right? So, way back when math was much easier, remember that equation? Dirt? D is equal to RT. So therefore, T is equal to distance over the rate. And I have 2 times. I have the swim time, and I also have the walking time. And it's going to add up together to give me the total time. And I'm going to call that T of X. And I can do that right now because you only see one variable here. The way I labeled it. I didn't go for Y. I kept it as X. Alright. So if time is d over r, I need a fraction right here for my swim. How can I find the distance? Well, the distance is right here. How do I show that? Come on, guys. Pythagorean theorem, right? The square root of 2 squared plus x squared. Pythagorean theorem. Over the rate. What's the rate for swimming? 2 miles an hour. So I'm going to come over here for this walking rate, which is going to be over 4. You see it? It should start coming together right now. Oh, that's okay. I can see it now. What distance am I going to put for the walking?
The square root of 1 plus 3 minus x squared.
Yeah. So the square root of a squared plus b squared. Can you imagine doing this by hand? The derivative? So that's why we have the calculator for these. Okay? But nonetheless, this is my time function. That all I have to do is the first derivative test with it, be done. Easy enough, right? All that work to do the most important part. Set it up. Any questions, guys, before I take the picture and start talking you through the calculator usage? Okay, here we go. So let's go to the calculator. Menu 1-4, menu 1-5. And we're going to do control divide control square root 2 squared plus x squared over 2 plus control divide control square root 1 plus the quantity 3 minus x squared over 4. This is all going to be stored. You tell me, what should I name this? T of x. Okay. And now we're going to find the derivative. Again, I want you to write the derivative, and I want you to write it equal to 0. Okay? So here we go. The derivative, that button next to 9, is going to be in respect to x. We're going to put, what is the derivative of t of x? And we'll do what Hayden said today. I'm giving him math props all unit long. Menu 394. And I want to do a common denominator for this equation. Now look at that. Okay? I will set the top equal to 0. But that one I'm going to do very easily by using the calculator feature. But then the bottom is equal to 0. Okay? For the sake of time, let me just do it real quick. Menu 3-1. It'll be 4 times the square root of parentheses x squared plus 4 times parentheses x squared minus 6x plus 10. And it's all going to kick out, set equal to 0, because we know the critical points also occur when the denominator is 0. There's no place when that happens. Do you understand? So there's no 0 on the denominator. So the only time it's going to exist is when the numerator equals 0, which is menu 3-1, when the derivative in respect to x of my said time function, kick out 1 is equal to 0, solve for x, there's my value, 1. Let me go up just to make sure that there aren't any decimals, and sure enough, there aren't. So 1 is going to be the value for that one. Okay? So what I want you to do for good practice is I want you to insert this as your derivative function. Okay? And just set it equal to 0. So you could write all that and put it equal to t prime of x. And you could put it like equal to 0 right next to it. Okay? So we would write all that stuff, and I'm running out of time. That's why I'm just going to say that just put all the derivative there. Okay? So, in fact, you know what I'll do to make it easier so that you have it? Is that when we first put the derivative in the calculator, we got something that looked like this. This right here. So if you want to write this as your derivative, you're okay to write that as well, which I will most likely do because it's a lot easier than the other way. Okay, so let's go ahead and do that real quick. So we have x minus 3 over 4 root x squared minus 6x plus 10 plus x over that. What AP is looking for is, did you find the derivative and did you set it equal to 0? Those are points on a free response question. Okay? Alright. So now we found that our value was at 1. So t prime of x, the only critical point was at 1. And what we're going to do is we're going to quickly sign test this to the left, and we're going to sign test it to the right. Just a quick verification because we need justification, right? So here we go. So we will go back here, and we're going to do menu for 2. Let's say to the left, let's say 0.5. And we're going to put our stored function t of x, and we get a negative. Let's say we kick to the right of 1, like 1.5, we get a positive. So very quickly, I just verified that this will in fact have that change that we were looking to find at minimizing something. Okay? Any questions before we start writing our stuff? Alright, so here we go. We're going to put, per first derivative test, and you don't, I see what you were asking now about the absolute. You don't necessarily need the absolute. You could just put the minimized time is going to equal something, right? When x is equal to what? 1. And remember, what did x represent? Mile, right? So when x is 1 mile, so the minimal time is going to equal something when x is equal to 1 mile. And remember, it said to what point on the coast should he swim in order to reach the town as quickly as possible. So I think that you should say, to answer that question, just something like he should swim to 1 mile down the coast. And what that is saying, guys, is that this right here is that 1 mile. Okay? To minimize the time, which all we need to do now is just put 1 into our original position function. So we would literally put, what is t of 1? So we could just say, what is t at 1? And we get 1.677. So the minimal time, you help me out please, would be what?
1.677
Hours, yep. And then, wait, what?
677.
It's 677? Okay, thank you. 677, not 667. When x is 1 mile, because what? Yep. Yep, because there's only, one critical point, which is x equals 1, where what? T prime of x changes from negative to positive.
So in your justification, do you have to write that he should swim 1 mile down the coast?
He should swim 1 mile down the coast. Yes, because this is what you're answering. What do y'all think about that one? Not too bad? It's just a lot of work, right? You got to keep track of everything for sure.